All right, so this lesson is going to be about identifying, defining, and applying arithmetic and geometric sequences. So those are two words that are maybe new vocabulary words, but it is a same concept that we have dealt with since you're probably in pre-algebra. Arithmetic and geometric sequences. So our goals today are to be able to extend a pattern, to be able to identify a sequence as either arithmetic or geometric, so knowing the difference, being able to identify the common difference or a ratio, and then be able to write the explicit definition of an arithmetic or geometric sequence and use it to find a given term. So that seems like a lot, but we will dive right into it. And our goal as we're working through this whole lesson is I want you to be thinking about how do you determine if a sequence is arithmetic or geometric. So by the end of class, you're going to be able to answer these 4 questions. You're going to be given a series of numbers. Those are our sequences. And you're going to be able to answer specific questions about those using our learning for today. All right, so the first thing is to be able to extend a pattern. So what I'd like you to do is I'd like you to pause the video and I'd like you to either use guess and check or use some sort of mathematic problem solving that I know you have the ability of to continue these patterns and fill in the missing pieces of the sequences. All right, so hopefully you were able to see the patterns that existed and find those missing numbers. So when I look at the first one, I see that it's going up by 3 each time. So 7 plus 3 gives me 10. On this one, there was a couple of ways you could think about it. I noticed that from 19 to 23, it's going up by 4. So when I go back to 7, 7 plus 4 is 11, plus 4 is 15, plus 4 is 19. So that fits. Now on C, it's a little trickier, and I'm going to tell you how I thought through this. So I know it's going up by the same amount each time. So it is going up by 1, 2, 3, 4 times to go from 8 to 32. So I found the difference between 32 and 8. So I did 32 minus 8, and I got 24. And so between 8 and 32 is 24, and it's changing 4 times. So I took that 24 divided by 4, and I got 6. So 8 plus 6 is 14, plus 6 is 20, plus 6 is 26, plus 6 gives me 32. Here it's going up by 8. 3 plus 8 is 11. 11 plus 8 is 19, plus 8 plus 8. And then here, 33 to 39 is 6. So if I do 33 minus 6, I get 27, minus 6 is 21, minus 6 is 15. So multiple ways to think through that, but hopefully we're able to extend that pattern. All right, so those before were going up by the same amount every time. So now when I look at these patterns, I notice that I'm not going up by the same each time. So now instead of adding and subtracting, we're going to be multiplying or dividing. Whether the sequence is going up or going down is going to tell me. So I want you to pause. Yes, there are some fractions, but I'd like you to pause the video and I want you to try really hard to see if you can extend these patterns that are being multiplied or divided. All right, so for this one, hopefully you were able to work through the following. So in A, I noticed that where I noticed the pattern was up here. I wasn't really sure what was happening with the fractions, but I noticed to go from 2 to 4, you times 2, times 2, times 2. So as I move this way, if I multiply by 2, as I move this way, I'm going to divide by 2. So 2 divided by 2 is 1, divided by 2 is a half, divided by 2 is 1/4. All right, on this one, I went ahead and said 189 divided by 63 because that would tell me what is the factor that's being multiplied or divided. So 189 divided by 63 gave me 3. So I know that if I take 189 divided by 3, I'll get 63. So then 63 divided by 3 gives me 21, and 21 divided by 3 gives me 7. All right, on this one, it's actually going down. The numbers are getting smaller as I move this way. So I'm dividing. Here, if the numbers are getting bigger as I move to the right, then I'm multiplying. And as I move to the right, if they're getting smaller, I'm clearly dividing. So what I noticed was to go from 1 to 0.5, this is 1/2. So from 1 to 1/2 would be divided by 2, and 1/2 divided by 2 is 0.25. So if I divide as I move this way, then I'm multiplying. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. So it fits the pattern. On this one, I noticed that it's going negative, positive, negative, positive, negative. Well, the only way that I can change signs is if I multiply by a negative. So if I took -4 and multiplied or divided by a negative, I would get a positive. And then a positive times that same negative number gives me a negative. And then a negative times that same negative number gives me a positive. And then the positive times a negative gives me the negative. So that's how it's alternating, is because my factor that's being multiplied or divided is a negative. And so when I think about going from 4 to 12 to 36 to whatever to 324, I'm multiplying by 3. 4 times 3 is 12, 12 times 3 is 36, 36 times 3 is 108, and 108 times 3 is 324. And then in order for that negative to happen, this is actually times -3 each time. All right, on this one, I see it's getting bigger, so I'm multiplying by something. But in order to figure it out, I'm not sure what's happening with this 3/4. So I'm going to jump over here to 3 to 6. So to go from 3 to 6, I multiply by 2. So as I move this way, if I multiply by 2, as I move this way, I have to divide by 2. So 3 divided by 2 is 1.5. 1.5 divided by 2 is 3/4. And that you may have gotten for this 3/2 or 1 and 1/2. Any of those would be acceptable answers, just as long as they're equivalent of 1.5. All right, so we're going to continue in extending a pattern. I want you to find the first number of each sequence. Now, I'm not going to tell you whether it's going to be adding or subtracting. You have to look for that pattern, or if it's multiplying or dividing. But I need you to be able to work backwards in order to find that number. So remember, as I'm going this way, if it's getting bigger, I'm either adding the same number every time or multiplying. And then if it's getting smaller as I move this way, then I'm either subtracting the same number if it's a common difference, or I'm dividing. So go ahead and find that pattern and apply it to find the first number. All right, so as you work through these, hopefully you were able to get the following numbers as the first number in the sequence. So I noticed for the first two patterns, it's going up by a constant rate. So that's going to be more linear. So I noticed that if I added 5 each time, so to get to the first number, I'm going to subtract 5. And here I noticed the pattern was to add 2, so to get back to the first number, I'm going to subtract 2. Here I noticed that we were multiplying by 2 in both of these situations. So in order to find that first number, I'm going to divide by 2 to work backwards. And in this one, the numbers were getting smaller, so I was subtracting 3. So to get back to that first one, I'm going to add 3. All right, so that is our first sub-objective, is just to be able to extend a pattern, to be able to find what's happening, whether it's multiplying, dividing, or adding and subtracting, and then extend that pattern to find either the next number, missing numbers, or the first number. All right, so you are going to be talking today about arithmetic sequences and geometric. So the first one we're going to talk about is arithmetic. So arithmetic is a linear sequence, meaning it has a constant rate of change. So it's going to be adding or subtracting that same number every time. So this is the explicit formula for arithmetic sequences. So a sub n equals a sub 1 plus d times n minus 1. And I just want to point out, you may see it where the d is at the end. That doesn't change anything, it's just putting it in a different place. So a sub n is the nth term, and so a sub n is the output given that nth term. A sub 1 is the first term in the sequence, so just the very first number that's in line. D is the common difference, so what am I adding or subtracting every time? And then n being the term number minus 1, so that's the input. So what is the output at a given term number? So when I say term number, I'm talking about the fifth number in the term. So I would plug fifth number in the sequence. So I would plug 5 in and calculate all of this, and that would tell me the value of the fifth number. So that is the arithmetic sequence formula. So the geometric sequence. A geometric is just an exponential sequence. So where I have that common ratio. So I'm multiplying or dividing by the same value every time. So if you remember back to Algebra 1, we talked a lot about exponential. Even in our last module, we talked about exponential functions. So I'm multiplying by a same or dividing by the same number every time. This is the explicit formula. So all of the letters represent the same thing. They're just in a different place. So a sub n is still my output given a specific term number, except for now, because it's exponential, my nth term goes into the exponent. I still do n minus 1, and I still have a sub 1. However, now I'm taking that first term, that starting point, and I'm multiplying it by my common ratio. So my common ratio is just what am I multiplying or dividing that value every time by. That is our geometric sequence formula. So these are the guiding questions that I use when I'm thinking through these problems. So go ahead and pause the video and I want you to write down these questions. So what is the pattern? And I'm looking for, am I adding or subtracting, or am I multiplying or dividing? Which formula should I use? So if I'm adding or subtracting, I'm going to use the arithmetic formula. If I'm multiplying or dividing, I'm going to use the geometric formula. Which formula, what is the first term? Because that's what goes in for a sub 1, the 1 being the first position. What is the value of that? What is the common difference or the common ratio? So I would plug that in for D if it's a common difference, or R if it's a common ratio. And then how do my values fit into that formula? That's where I'm plugging everything in. And then if it's arithmetic, how can I simplify the formula? And I'll show you what I mean by that in just a second. All right, so let's go ahead and apply the arithmetic and geometric sequences in order to write a function and then use that to find specific values. All right, so the first question is, what is the pattern? So I see I'm going 7, 10, 13, 16. So it is increasing. So it's either going to be adding or multiplying. But when I think about 7 to 10 to 13 to 16, it's not increasing very fast. So it's probably not going to be multiplying. It's probably going to be adding. So 7 to 10 would be to add 3. 10 to 13 would be add 3, and 13 to 16 is add 3. So it is a common difference. So which formula should I use? I should use the arithmetic. So that was a sub n equals a sub 1 plus d times n minus 1. And that's going to allow me to find specific terms in this linear pattern. All right, so what is the first term? Well, the first term is going to be 7. So that is a sub 1. So 1 is the position. So the first position, the value is 7. And then what is the common difference or the common ratio? And so we know that it's not going to be a ratio because I'm not multiplying. So D is going to be positive 3. So if it were negative 3, if it were going backwards, D would be negative 3 when I plug it in. All right, how do my variables fit into the formula? So just like we keep x and y, so we have y equals mx plus b, and we just plug in my slope and my y-intercept, same thing here. We're going to keep it as a sub n, that's just my output, equals, I do know a sub 1 is 7, and then my common difference is a positive 3 times n minus 1. So n is my input, so that's like my x value, and a sub n is my output, that's like my y value. So this is all that needs to go into that formula is my first term and my common difference. Now, the last question is, if it is arithmetic, how could I simplify? And what we're going to do is, just to make our lives easier, we are going to distribute. So this becomes a sub n equals 7 plus 3n minus 3. So really, my formula is a sub n equals 3n, and then I put 7 and negative 3 together, and I get plus 4. So that is my function that I can put any n value, any position in, calculate it, and it will tell me the value or the output at that specific position. So I can try it out. Let's try 10. 10 is the second term. So if I put 2 in, 3 times 2 is 6 plus 4, my output is 10. If I put 3 in, 3 times 3 is 9 plus 4, I get 13. So it's working. My function is correct. So now the last thing we're going to do is we are going to use that to determine the 19th term. So 19th is the position, so that's the input. So when n is 19, what is that value or what is that output? So I'm going to say a sub 19 is 3 times 19 plus 4. I'm just putting that in for n. So a sub 19, which shows the 19th position, is going to be 3 times 19 plus 4. So 3 times 19 plus 4, I get 61. So the 19th term is going to be a value of 61, which I would have found if I would have just kept adding 3 all the way out till I did it 19 times, I would still be at 61. But the formula is going to give me a much faster way of getting there. All right, so for example 5, we're going to go through that same process. So we're going to start with what is the pattern. So am I adding, subtracting, or am I multiplying, dividing? So when I look at it, my first inclination is the numbers are getting smaller. So it's going from -2 to -4 to -8 to -16. So they're progressively getting smaller. So when I think about how I get from -2 to -4, I would subtract 2. But if I take -4 minus 2, I would get -6, not -8. So that automatically tells me that I am multiplying by something or dividing by something because it doesn't have a constant rate of change. So what I notice is all the numbers are negative. So the only way that I can take a negative number, multiply or divide it by something, and get a negative number is if that value is positive, because a negative times a positive value is negative. So that's what keeps it negative. So 2 to 4, 4 to 8, 8 to 16, I know that I'm multiplying everything by 2. -2 times 2 is -4. -4 times 2 is -8. And -8 times 2 is -16. So which formula should I use? This is a geometric sequence. So my formula is going to be a sub n equals a sub 1, my first term, times r to the n minus 1. All right, so what is the first term? So the first term, that a sub 1 is -2. And what is the common difference or common ratio? Since this is a geometric sequence, we have a common ratio. And that common ratio is times 2. So 2. All right, so how do the values fit into my formula? So a sub n is -2 times my r, which is 2, to the n minus 1. And because this is not an arithmetic, I can't simplify that any further. So that last question, if it's arithmetic, which it's not, it's geometric. So that becomes my formula. So now I can use that function to determine the 16th term. So a sub 16 equals -2 times 2 to the 16 minus 1. So I can literally just type that in exactly how I see it in my calculator, or I could simplify it to a sub 16 equals -2 times 2 to the 15, because 16 minus 1. Either way, I'm going to type that into my calculator, and I'll end up with -65,536, which makes sense because I can tell that it's going to be negative, because if I multiply a negative by a positive every time it stays negative, and it's going to be a really negative number. Now, I will tell you one quick method is if you typed this into your y equals, so if you went to your y equals, typed in -2 times 2 to the n minus 1, and make sure that minus 1 is part of the exponent, and you went to your table, we're looking for when the input is 16, so I could scroll down to when x is 16 because that's the input, and it should give me that -65,536. All right, so for example 6, I'd like you to pause the video, and I'd like you to write the function and then determine the 10th term. All right, so hopefully you were able to get this as your function. A sub n equals 1 times -6 to the n minus 1. And when you calculated that and used found the 10th term, hopefully you were able to find that it's -10,077,696. Go ahead and look over my work and make sure that yours matches up. All right, pause the video, and I'd like you to try number 7, example 7 as well. All right, so hopefully you noticed that this is an arithmetic sequence because it's going down by 21 every time, so it has that constant rate of change or that common difference. So when I plug that into the formula and simplify it, because it is arithmetic, I get negative 21n plus 407, and then I find the eighth term by plugging 8 in, and the eighth term is 239. All right, so example 8, we have 3 more examples. So go ahead and pause the video and try this one on your own. All right, this one was as well an arithmetic sequence. And so when I found the first term and the common difference and plugged it in the formula to simplify, I got a sub n equals negative 11n plus 6. And then a sub 9 is going to be negative 93. All right, so now we're going to work with some decimals. Same process. It's just that our numbers aren't whole numbers. So go ahead and pause the video and try this one on your own. All right, so with this one, just because it's decimals doesn't change anything. It's still, I see that it's going down by 4/10 every time. So that's going to be my common difference. And when I simplify it out, I get a sub n equals negative 0.4n plus 1.3. And I use that to find the 11th term, which is negative 3.1, which makes sense because it's going down. All right, this is our last example in this lesson, so I'd like you to pause the video and see if you can determine the function and the fourth term. All right, so this one was a little tricky, but hopefully you were able to figure out that it is being divided by 6. Now our formula is a sub n equals a sub 1 times r. So dividing by 6 is the same, multiplying by 6 is the same as dividing by 1/6. So whenever I'm dividing, I'm going to make it a fraction. Taking a sixth of something is the same as dividing by 6. So this would be my function. And then to find my fourth term, I go ahead and plug 4 in, and that gives me 1. All right, so we have met our goal today to be able to identify, define, and apply both arithmetic and geometric sequences. We were able to find those patterns, extend them, and then look at a sequence of numbers and determine if it was arithmetic or geometric, and then find that common difference or ratio, and then write the explicit definition of the arithmetic or the geometric sequence, and find a term number. So I'd like you to please pause the video. I want you to think about what are some common mistakes that students make. Write those down so you make sure you don't make those. I want you to come up with some sort of summary. So what questions do you have? What do you understand? How can you remind yourself of this concept? And then the last thing is rate your understanding on a scale of 1 to 3.